Hi students, thank you for watching this practice test video. All right, let's get started. Okay, so question number 1, we want to go ahead and graph our parent function first, or find out the coordinate points of our parent function. That's going to be 3 to the x. And then we have our x values. We always use -1, 0, and 1. And then 3 to the x is just going to be 3 to the -1 is 1/3. 3 to the 0 is 1. 3 to the first power is just 3. Next, we think of our transformations, right? So our transformations, this -1, that's going to be our a, that's going to be our h, and that's going to be our k. All right, so remember, a and k only affect our y values. I don't know why it keeps on not focusing, but anyways, so it's going to be -y minus 4, and then we have, well, x plus 2. That h is going to affect our graph. It's going to move it to the right 2. All right, so each of these x's plus 2, that's going to be -1 plus 2, that's 1. 0 plus 2 is 2. 1 plus 2 is 3. And then next, multiplying each of these by -1 and then subtracting 4 from it. So -1/3 minus 4, that's going to be about -4.3. -1 minus 4 is going to be -5. And then taking this 3, -3 minus 4, that'll be -7. All right, so graphing these points, that's going to be 1, 1 comma -4.3, that'll be about right there. 2 comma -5. And then 3 comma -7. 3 comma -7. Be about right there. And then remember our horizontal asymptote. Our asymptote is going to be our h value. All right, I apologize. Our k value. So it's going to be -4. Remember, asymptotes for exponential functions are going to be horizontal. Right? So asymptote. Remember, y is equal to -4. All right, and then now we need to create the general shape of our graph. Remember, it's going to look like it's going to touch that asymptote, but never does. All right, there's our graph. So the furthest left our graph goes is -infinity. Furthest right our graph goes is +infinity. Our range, the furthest down it goes, is -infinity. The furthest up it goes is +4. All right, transformations. We are going to go ahead and look at our A. Our A tells us, well, it's a -1, so it says reflect, or it tells us it's going to reflect down. All right, what else do we have? Well, we have that H, that -2 tells us it's going to move to the right 2. And then the whole punch cut it off, but there's one more transformation. That K tells us it's going to move down 4. All right, end behavior. As x goes all the way to the right, all the way to infinity, our graph moves downward. So our f of x goes to -infinity. As x goes all the way to the left, the height of our graph goes to -4, right? It keeps on going up and up and up, but to -4. And our y-intercept is, well, we plug in 0 for x, and that's why we find our y-intercept. So -3, 0 minus 2, minus 4. All right, so that's going to equal, well, we can just put this in our calculator. Let's see, -3 raised to the -2nd power, right? 0 minus 2, and then minus 4 gives us an answer of -4.1. So our y-intercept negative, or we could just put 0, -4.1. All right, and that is how we go ahead and do that exponential function problem. All right, next we have our formula problems, our exponential functions relating it to sort of like real world problems. All right, so with question number 2, it says you inherit 20,000, but unfortunately a banking error causes you to lose half of your money every 6 months. Even worse, the error goes unnoticed by you or the staff for 3 years. how much money of the 20,000 do you have left? So of the 20,000, it says that we lose half. That's going to be a hint that we use the half-life formula, right? So a sub 0, that's what we just start off when we have 0 time that passed. So 20,000 multiplied by 1/2. And then all of that raised to the t power. So t, our total time is in 3 years, right? So 3 years. And then our half-life, we lose half of our money every 6 months. So our half-life is 6 months. But notice how this is in 3 years. So we need to make 6 months into, well, how many years is that? That's 0.5. And then we could just put this into our calculator. So if you guys remember from the lesson, I told us to do this first, and then we can put it in your calculator. So 3 divided by 0.5, if you put that in your calculator, that'll give us 6. So entering it just straight into our calculator, we get 20,000 multiplied by, well, 1/2 is just 0.5, and then all of that raised to the 6th power. So we get $312.50. All right, question number 3. Miss Curry's TikTok profile is starting to gain subscribers for extraordinary dance moves. She starts off with 3,000 subscribers, but by day 1 has already increased that subscriber count by 80%. If the number of subscribers continues to increase at the same rate for the next 7 days, how many subscribers will Miss Curry have? All right, so if we look at our formulas, we want to try to understand, well, which formula do I use? Well, it's definitely not going to be either of these two, right? These are when it says compound something, compound interest. So it doesn't say compound interest. It doesn't tell us anything about a half-life, so we're not going to use that one. And then now we just narrowed it down to just these two. Well, we know it's not going to be this one because this one's going to be decreasing. So that leaves us with that one. So it tells us we start with 3,000, so that's our A. 1 plus our rate as a decimal, that's going to be 0.8. And then all of that raised to, well, they tell us 7. So entering that into your calculator, 3,000 multiplied by 1 plus 0.8, all of that raised to the 7th power. We get 183,666. We're just going to round to the nearest whole person. So 183,666 subscribers. Or followers. I know someone told me it should have been followers. But yeah, that's how I do that problem. All right, question number 4. Logan and Nate wisely decide to invest some money to save up to become better volleyball players. They invest $2,500 in an account that earns 3.5% compounded continuously, right? 3.5% compounded continuously. How much money would they have after 8 years? So huge hint right here, compounded continuously. If we look at all of our formulas, right, compounded continuously, as I said before, these are our compound interest formulas. But when it says continuously, that means we're going to use this formula, right? All right, so P, our principal, we start off with 2,500. We multiply it by, well, scratch that out. It should be 2,500 E raised to the, well, 3.5% as a decimal. That's going to be 0.035 multiplied by time, T, which is 8 years. All right, so if we enter that into our calculator directly, right, 2,500. Second, this button to get that E, 0.035 times 8. That gives us $3,307.82. All right, so that's how to think through those word problems and what formula to use. All right, question number 5. And we have our log. Our log functions. Remember, log is just the inverse of the exponential. So we're going to take this exponential function. That's going to be our parent function. We're going to write that, and we're going to start it off the same way as we did the exponentials, right? Negative 1, 0, 1. 2 raised to the negative first power is 1/2. 2 raised to the 0 is just 1. 2 raised to the first power is 2. Next, remember that middle one. Why do we have that middle one? Because we go ahead and invert it. 2 to the x, and then x. So we just have 1/2, 1, and 2. We switch those x's and y's. Negative 1, 0, and 1. All right, next we look at our a, h, and k's. Remember, our a, which is our 2, and our k affect our y values. So we're going to write 2y minus 4. And then we don't have an h here, right? If we had an h, it'd be in parentheses, but technically there's no parentheses, so we just assume it's nothing. So our x just stays the same. So same x values, 1/2, 1, and 2. And our y values, we take each of these values and we multiply it by 2 and then subtract 4. So negative 2 minus 4 gives us negative 6. 2 times 0 is just 0. 0 minus 4 is negative 4. And then 2 times 1 minus 4, that'll give us negative 2. All right, so we have those decimal points. Let's go ahead and graph them. 1/2 comma negative 6 would be about right there. 1 comma negative 4 would be about right there. And then 2 comma negative 2 would be about right there. All right, next we go ahead and graph our asymptote. Remember, our asymptote for logarithmic functions are going to be vertical asymptotes. So it's going to be at our h. But remember, we said we don't have an h, so it's just going to be assumed to be at 0. And then we go ahead and graph our function. Well, it's going to approach this, but it never touches that 0. So it's going to look something like that. All right, our domain. Our domain is the furthest left our graph goes, which is 0. Then the furthest right our graph goes, which is infinity. Our range is going to be from negative infinity, right? The lowest our graph goes is negative infinity. Highest our graph goes is infinity. Asymptote. Well, we said it was 0. Remember, specifically it has to be x is equal to 0. And then transformations. Well, transformations, we said that we have the a there. That 2 tells us it's going to stretch by 2. And then remember, our only other transformation is that k value, which moves it down 4. All right, end behavior. As x goes, well, this time we're trying to see where are we moving left or right when our the height of our graph gets higher and higher. So we're going to the right. As x goes to infinity, the height of our graph gets higher. Right, so as x goes to infinity, height of our graph gets higher. As x goes to 0, as x goes to the left, the height of our graph gets lower, and that makes sense, right? So as we go this way, the height of our graph goes down. And our x-intercept, this is where we plug in 0 for f of x, right? Or y. This is technically our y. So 0 is equal to 2 log base 2 of x minus 4. And then we go ahead and solve for x here. So we have to add 4 to both sides. We get 2 log base 2 of x is equal to 4. Then we divide both sides by 2. All right, I'm going to continue over here. We get 2 on the left-hand side, right? 4 divided by 2 is 2, is equal to log base 2 of x. And then here we can go ahead and, well, we can sort of rewrite it in our exponential form, right? Remember, our exponential form is just going to be, well, we're going to take this number, our base of 2, and then whatever it's equal to, 2 raised to the second power is equal to x. Remember, that's just our switching our logarithmic form. We get 4 is equal to x. sorry, our x-intercept is 4 comma 0. So I guess to be more accurate on my graph, I could have graphed it like that. But I mean, I won't be so picky as long as you have it over here as that being correct. All right, question number 6. We have 3 log 5 x squared minus log 5 of y. So we have two separate log functions. So our job is to go ahead and put it into one log expression. So remember with this 3, we can go ahead and move it up. We could rewrite it as log base 5 of x to the 6 minus log base 5 of y. Right? And then remember, just from the rules, I'll give you guys these rules on the test, but anytime you have two log expressions with the same base and they're subtracting, we can go ahead and divide both of these. So we're going to rewrite it, log base 5, and then we're going to create our fraction. This x to the 6 goes on top, that y goes on the bottom, and that's our final answer for that one. All right, log base 3 of the square root of 5w. Remember, log base 3. So we have two separate, not two separate. We have a fraction, right? So now we have one log expression. Now we want to sort of split them apart. So when we have division, just like we did this over here, right? Now we're going to do it reverse. We start with this. We can put it into two separate ones. So log base 3 of our numerator minus log base 3 of our denominator. And then now we need to rewrite this as an exponent, right? The square root, we could write it as an exponent of 5w to the 1/2 power minus log base 3 of 4. And if you remember, like we can move that 1/2 down, right? Anytime we have an exponent. So it's going to be 1/2 log of 3, 5w, minus log base 3 of 4. And then lastly, remember when we have one log expression with multiplication, we could split these two up using addition. So we're going to write 1/2 log base 3 of 5 plus, well, we still need that 1/2 log base 3, and then we're going to take care of that w. And then we're just going to bring this down. So that would be our final answer. And a good hint to know how many log expressions we should have, right? 1, 2, 3. If we look at what we started with, 1, 2, 3 different factors. So yeah, we have 1, 2, 3 different log expressions. All right, now with number 8, we start with 3. We should have one log expression at the end. So same thing as we did with 6. We're going to move this 1/3 up. We're going to move that 2 up. And then we're just going to keep that the same. That doesn't have anything. All right, so log base 3. Well, if we move it on top of the 64, so it's going to be 64 raised to the 1/3, we know that that's the same thing as finding the cubed root of 64. So the cubed root of 64 is just 4. Plus log base 3 of, well, 3 squared. 3 squared will give us 9. Plus log base 3 of 2. And then now we know that there's addition in between each of these, so we can combine it using multiplication. So log base 3, and then we're just going to multiply each of these, right? 4, 9, and 2. So 4 times 9 times 2. Multiply that in calculator, you'll get log base 3 of 72. All right, on to the solving part. Well, we want to get this term by itself first, so you add 10 to both sides. Right, we get 3 raised to the 7 minus x is equal to 9. Next, we go ahead and, well, we do log of both sides, right? Because if we do log of both sides, we can bring down the 7 minus x. All right, so now we could rewrite the 7 minus x at the front. log base 3, that's no longer an exponent, right, is equal to log base 9. And then now we divide both sides by log of 3. We get 7 minus x is equal to, type in your calculator, log base 9 divided by log base 3 gives us 2. Using mental math there, 7 minus what number is equal to 2? Well, we know 7 minus 5 is equal to 2, so x is equal to 5. Question number 10. I went over this one in class, but that's just the same thing as writing log base e of 3x minus 7, which is equal to 5. All right, so now to cancel out our log base e, we have base e on both sides. Right, that'll cancel that out. So now on the left-hand side, we're just left with 3x minus 7. On the right-hand side, we have e to the 5th. So e to the 5th in our calculator, second e to the 5th, that's going to be about 148.4. We're going to add 7 to both sides. We get 3x is equal to, 155.4. And then we're going to divide both sides by 3. So let's see, I'm going to add 7, divide by 3. And we get x is equal to about 51.8. All right, question number 11. We subtract 19 from both sides. We get 9 times 2 raised to the x plus 5 is equal to 144. We divide both sides by 9. We get 2 raised to the x plus 5 is equal to 16. All right, so I'm going to show this one another way to look at it. Well, we know 16, we could rewrite it as base 2, right? 2 to the 4th power. So we have 2x plus 5 is equal to 2 to the 4th power. All right, so since they have the same bases, they cancel out. X plus 5 is equal to 4. Subtract 5 from both sides. We get x is equal to negative 1. All right, question number 12. All right, subtract 2 from both sides. We get 4e to the 2x is equal to 14. Divide both sides by 4. We get e to the 2x is equal to, well, 14 divided by 4 would be 3.5. Next, we take the log of both sides, right? So we can bring that 2x down. So we bring the 2x down. Now it's going to be 2x multiplied by log of e, which is equal to log of 3.5. Divide both sides by log of e. We get 2x is equal to, we can just put that in our calculator, log of 3.5 divided by log of e, second e. Well, it's just to the first power, so we put that 1. We get 2x is equal to 1.25. Let's divide both sides by 2. We get x is equal to, divide both sides by 2. It says to round to the nearest 10th. Right up there, it says round to the nearest 10th. So we could just say x is equal to 0.6. All right, last log problem solving. 4w minus 15, well, that's one log expression, but over here we have two separate log expressions. So we sort of need to do what we did on that last section with combining logs. That's going to be equal to, remember, anytime you have subtraction in the middle, we write it as the same log base, but then you divide each of these, right? 100 divided by 4, that'll be log base 5 of 25. On the left-hand side, we have log base 5 of 4w minus 15. And then now we go ahead and cancel out our log 5s, right? Same base, so they just cancel out. 4w minus 15 is equal to 25. Now we go ahead and add 15 to both sides. We get 4w is equal to 40. And then divide both sides by 4. We get w is equal to 10. All right, our factoring problems. Definitely going to have factoring on the test. All right, so if we look at this, our greatest common factor of 3x squared and 18x is going to be 3x. Right, dividing each of those by 3x, we get x minus 6. All right, so that's going to be our factors, 3x multiplied by x minus 6. Our zeros are what we get when we go ahead and solve this equation. So we set each of those equal to 0. 3x is equal to 0. Or we could have, I'm just going to write it up here, x minus 6 is equal to 0. All right, so dividing that by 3, we get x is equal to 0. Adding 6 to both sides here, we get x is equal to 6. So our zeros, 0, 6. That's how you do number 18. All right, question number 19. Same thing as we did with 18. We always look for our greatest common factor. Greatest common factor of this is going to be 5 and x. Dividing each of these by 5x, right? 5x cubed divided by 5x is going to be x squared. 50 divided by 5 is going to be 10. X squared divided by x is going to be x. And then 120 divided by 5 is going to be 24. And then x divided by x is going to cancel out. All right, so we took out our greatest common factor. But remember, anytime we have a quadratic trinomial, we can go ahead and factor that more. Right, we can factor it more using our x method. Look for two numbers that multiply to 24, adds up to 10. That'll be 4 and 6. 5x multiplied. Remember, we could rewrite it in factored form. X, and then our two numbers, plus 4, plus 6. So yeah, that's our fully factored form. Our factors are 5x multiplied by x plus 4 multiplied by x plus 6. Our zeros, this is going to be where we solve for our different factors. 5x is equal to 0, x plus 4 is equal to 0, and x plus 6 is equal to 0. So solving each of these functions for 0, or for x, we get x is equal to 0. Subtract 4 from both sides. We get x is equal to negative 4. And then subtract 6 from both sides. We get x is equal to negative 6. Sorry, I guess I should have maybe wrote it down here. But yeah, those are our 3 zeros. So 0, negative 4, and negative 6. All right, question number 20. Once again, our greatest common factor, we always factor it out. That'll be 2. In parentheses, we have x squared minus 100. So remember, we can recognize that these are perfect squares, right? So we can go ahead and split this up into x and x, the 100 into 10 and 10. And then now we could rewrite it in this difference of squares technique. If you guys remember, we'd have two of them. It's going to be, one's going to be plus, one's going to be minus. And then in the spaces, it's going to be, our first spaces is going to be x. Our next spaces is going to be 10. Yeah, so that's our fully factored form. 2 multiplied by x plus 10 multiplied by x minus 10. And our zeros are what you get when you solve these equations. So remember, an equation has x in them. So this doesn't have x in it, so we don't have to worry about that. But x plus 10 is equal to 0. X minus 10 is equal to 0. Subtract 10 from both sides. We get x is equal to negative 10. Add 10 to both sides. We get x is equal to positive 10. So our zeros here are 10, negative 10. And that is the end of our practice test.